Hi to everybody and welcome. So just a few introduction to our team. So I'm Roberto Turrin. I'm head of technology at Cloud Academy, an online platform to teach cloud technologies. And I have a few experience with recommender system and data science related tasks. With me today there is Andrea Cappelli, data scientist at Cloud Academy. And he has a long experience with natural language processing. And with us there is also our friend, our assistant, Amazonico. I would like to start presenting you our solution, and then we will show you how we realize this product, basically. I mean, it's just a toy, not really a product. So let's start with Echo. Do you have any questions?
Sure, I have one for you. In the episode Bart the Fink, who kills off his pseudonym in a boating accident in order to collect the life insurance, thus ending his tax woes. 1. Reverend Lovejoy, 2. Krusty the Clown, 3. Kang and Kodos, 4. Lionel Hutz.
You know the answer? Number 3.
I'm sorry. The correct answer was Krusty the Clown.
Okay, that's just what we did. And now let's talk about how we did it. So in very few points, that's our pipeline. We started collecting a knowledge source from Wikipedia. We processed this source using the Google Natural Language API, which is an NLP tool, basically. Then using this output, we collected entities and dependencies to generate questions. And finally, we integrate this output with Alexa. The first part. I guess everybody knows Wikipedia. I don't know how many of you know also Wikidata. Just a very few. So basically, Wikidata is a document-oriented database and represents information, a part of the information that is present in Wikipedia. The advantage of using Wikidata is that the information that is in Wikidata is very structured. That means that you don't have just a free text as Wikipedia, where you need text parsing in order to extract information, but there is already organized, and so if you need, for example, the title of something, you just search for the title. You don't have to parse a free text in order to find the section that is related to the title. Or if you need to know, for example, the, I don't know, that Florence is in Tuscany, where you just have this structured information and you query this database. So what the advantage of using Wikidata is that this information is represented by statements, and each statement, as by definition, is a key value pair. That means that every property can be mapped in this paradigm. That means, for example, that Florence is in Tuscany, that there will be a property that states where Florence is located. All we have is that we can query Wikidata. And there are several languages that we can use. The oldest one probably is the Autolist. Then this is next one is PetScan that replaced basically Autolist. And finally, we can use Sparkle. Again, how many of you are familiar with Sparkle? Just a very few. So I will give you just a few words about what Sparkle is. Imagine that Wikipedia can be represented by triples. And every information that you find in Wikipedia can be seen as this set of a resource, which is linked to another resource, or more generally, literal, through another resource. Everything in Wikipedia basically is a research. And for example, you can have these triples where you have a subject, you have an object, and you have a predicate that makes this subject matching with the object. Just to make a very simple example, if you think about the representation of this information, that is New York has the postal abbreviation NY. Then there is a resource, which is New York, and this is this URI. And this is this literal, which is NY. And again, the predicate that make this related to this is this other resource. So even predicates are resources in Wikidata. And that means that, for example, if we want to extract all the abbreviation of all postal abbreviation of all towns, then we just search for these predicates, and as results, we will have this abbreviation for any cities that is in Wikidata. Using this idea, we basically extracted the information that we wanted to use to generate our quiz game. And so first step of our pipeline is using Sparkle to retrieve this information, and we use this to extract information about some TV series. Then we used a simple REST API to download data from Wikipedia, and we downloaded it as XML. Then we used the Wikextractor, a Python program software in order to parse Wikipedia, the extract XML Wikipedia, and to get our reference knowledge. This will represent our statements in order to generate questions. Finally, we used the Google Natural Language Service in order to process this information that is free text and to extract some more useful metadata. Natural language processing is typically used to perform either syntax analysis or semantic analysis, or you can use it to recognize entities, or finally to extract semantic information. I will show you a very quick example of how to use this service. Let me go to open a browser. Okay, so this is the home page of this service, and here we can make a very simple demo. So let's try it with this sentence: Homer Simpson stole Ned's air conditioner. And in a very few milliseconds, we get these results, and this is the analysis that the service returns to us. First of all, we have three different analyses. One is about entities, another one is about sentiment, and the last one is about syntax. Entities is very useful because we extract the main objects of the sentence. And in this case, we have recognized that there is Homer Simpson, which is a single entity. We recognize that there is an air conditioner, which is again a single entity. So you recognize that these two words are part of the same entity. And we recognize that there is this person, Ned. You can see that for some entities, there is a link to a Wikipedia article, and this is useful in order to get all the information about these entities. Making another step, we can use Wikidata to extract very structured information. So if you want to know, for example, which series Homer Simpson belongs to, we can use Wikidata that has this structured information, for example. The salience that you see here is a number score that the service returns, and that basically represents the importance of this word or this entity for the sentence. That means that for this analysis, Homer Simpson is much more important than air conditioner and Ned, for example. Okay, this is the syntax analysis, and this is the most important part for us, because from this analysis we can extract dependencies between words of the sentence. And so, for example, we see that, first of all, we recognize the part of speech, we recognize that Homer and Simpsons are two nouns, that there is a verb which is stole. that there is this other noun which is ned, and finally this is the last part, again, two nouns. Again, important is that, for example, for the verb, we recognize that is in past, and the service also recognizes that the mood is indicative. As for the noun, we know that they are singular, and some of them are proper noun, some others are non-proper noun, so they are common nouns. The green arrows represents the dependencies between words. And so, starting from the root, which is typically the verb of the sentence, we know that it is linked to these two entities, which is represented by these two tokens, Homer and Simpson, and this is represented by this part of the tree. And we know that this is the subject, and we know that this other part is the object of our sentence. And this is linked by these other arrows. So basically, we have all the information that can be used in order to generate a question at this point. Just to conclude with this analysis, Google also presents a sentiment analysis, which represents the polarity of the sentence, which is either a positive, a negative, or a neutral sentence. In this case, it recognizes that it is a slightly positive sentence. So I will let Andrea continue and make you understanding how we use this information extracted from the Google service in order to generate these questions and integrate them into Alexa.
Thanks, Roberto. So, as Roberto said, now we have all the elements that we need for our analysis, and we can try to build or rearrange this information in order to get questions. That must be reasonable with respect to several criteria. What do we mean by question or quiz or whatever you want to like it, to name it? We mean that there must be a question that must be asked to the user, so a simple question, and a correct answer, so something that you are expecting the user to tell you and for which you are going to say, yes, you're right. But you also want to get some wrong answers, wrong alternatives that you want to present, which are not going to be correct. But it may sound strange, the wrong answers are the most difficult part when you want to generate something like this. Because a good wrong answer is similar to the correct answer. It's not clearly wrong, but obviously when you do something automatically, like we are trying to do here, you also do not want it to be correct as well. So it's not that easy to do something like this. And that's why we thought that we could try to use Wikidata to generate wrong answers. I will show you what we wanted to do. So first of all, we can get a sentence. We can go through all sentences of a given text of a given Wikipedia page, for example, and we can use the Google APIs to get the entities which are present in that sentence. So by entity, as Roberto said, we mean, in this specific case, important, relevant parts of the sentence, and specifically, we want to limit our analysis to those that have a Wikipedia link. Why? Because if we find the Wikipedia link, we also can map it to a Wikidata ID, so we can place the entity we have recognized in the graph of Wikidata. And we can do something more starting from that. I will show you what. However, once we have a sentence, we can easily do something on it in order to make it a reasonable question. For example, our first idea is to remove one part of the sentence and use the removed part as the correct answer you want to ask the user. In this case, we can remove Homer Simpson, and we can propose Homer Simpson and something else as possible fillings for that blank that we have created. One more thing, a bit more complicated, and for which we need the syntax analysis from Google. Up to now, we have used just the entity extraction. If we want to also use the syntax analysis, we can, first of all, get the tree. This is the dependency tree. I draw it so it's much uglier than the one you saw on the Google demo, but the idea is the same. You have parts of the sentence which depend on other parts of the sentence, and if you remove one of these, you also want to remove all those that depend on it, because otherwise the sentence is not going to sound correct anymore. If you remove conditioner, for example, and you don't remove all things that depend on it, like Ned's hair, you remain with Homer Simpson stole Ned's hair. In this case, it sounds correct, but it's definitely not the same meaning as before. Even more clear, you can try to remove Ned without removing the apostrophe S. In that case, you have Homer Simpson stole air conditioner. While if you remove conditioner and everything else, you have Homer Simpson stole, and it just sounds incomplete, not incorrect. If you divide the sentence, for example, in this case, removing the direct object of the verb, you can rearrange the question, the sentence, into a question like this. So, Homer Simpson is the part that we kept as it was. We have what did steal, which is built in our algorithm, using the fact that we understand that stole has a basic lemma, which is to steal, the verb to steal. And in this way, we can build something that was not exactly in the sentence, just a bit more complicated. And clearly, the part that we removed, Ned's air conditioner, is the correct answer of the question we have created. Up to now, we have the question, we have the correct answer. Still, we do not have the wrong answers. What can we try to do? We have Homer. If we have Homer, if we remove Homer in a different sentence, for example, and it's the correct answer, then we know its Wikipedia link and we know its Wikidata ID. And we can query Wikidata in order to see in which series he appears, for example, The Simpsons. Then we can follow the same kind of link backwards. So we know the series, we want to know all characters that appear in it. And this is clearly a way to get some characters of the series which might sound as reasonable wrong answers for a quiz like this. This is the idea behind all of this. I didn't show this thing specifically, but we can also keep track of several more information about these entities, like, for example, if they are male or female characters, so that you can limit the wrong answers that you propose only to those of the same gender of the one you have removed. So let's try to uncode. Actually, it's the complete code of the project. I will try to just go through some key parts. First of all, we have used several libraries, Python libraries here and there, and simply there is not a specific one without which we couldn't do the job here. But it's just too practical. It's just too practical to have all of them here together. Plus, there is Network X. I don't know if somebody has used Network X. It's a Python library for manipulating graphs and using algorithms on graph and just storing them, which is quite practical if we just want to, for example, avoid retrieving data from Wikidata all the times and just download everything we need the first time and store it locally as a graph. So what we did here was just creating some classes for manipulating easily the syntax information that we obtained. And specifically, it's important to have some traversal method for the nodes of the syntax tree, because in all cases we want to parse all nodes and just remove some of them which are going to be the correct answer and keep others. So you want to filter the nodes based on the logic of the sentence itself. Then here you have a method that we use to perform a query to Wikidata. As you can see, this is SparkQL language, the one that Roberto told about. And using this, you can create a graph. In this case, it's a digraph, a directed graph made using NetworkX, in which we actually downloaded information about all male characters for the series, all female characters, and then we created a joined graph containing the information for this. So whether the character was male or female, and we were able to select this attribute inside the algorithm. These are all handler methods, and this is the main analysis function we use to call the API from Google. It's actually nothing too complicated. It's about using requests and just parsing the output of the API, as you can see here. This is the kind of information that you get just in a format which is, yes, maybe a bit less graphical than what you saw before, but it's all the information you need. You have the name, the text of each token, the grammatical part of speech, and most importantly, the link to Wikipedia here and here. And these are those on which you build the remaining part of the algorithm. And these are the roles of that token inside the sentence. So you have the subject, you have the direct object, and all of the other parts are clearly also connected. You have the information about the dependency that you saw in the tree. So what we did was to, at first, retrieve all Wikipedia IDs for a given series, not to get the characters, but to get the Wikipedia pages for the episodes of that series. After getting that, we had a list of Wikipedia IDs for those episodes that we could map back to the Wikipedia pages. And after this, we were able to retrieve all those pages with the text. This was done using Wiki Extractor, which is a module developed at the University of Pisa, I think, which allows to parse the XML results that you get by querying the Wikipedia APIs. You have this Wikipedia API here that was very practical to just retrieve the specific pages that we wanted to analyze. Clearly, that specific module was thought to parse the whole Wikipedia dump, but clearly we were interested in a very, very small subset of all the pages that are in Wikipedia. So we just downloaded a few of them, and we were able to use the module just on those. And we limited our analysis to the plot section of the pages in Wikipedia and to the cultural references. Because we saw that they were looking like the more promising to have very affirmative and declarative sentences that could be used to generate the questions. Okay, so we just ran the analysis and retrieved the graph. This time, the graph I'm talking about, we are still using Wikidata, but we are not retrieving the pages for the episodes of a given series. We are retrieving the characters appearing in that series. So we used Wikidata for two main tasks: retrieving episodes and then analyze them, and retrieve information about the characters in the series. And this is the main class taking care of rearranging the sentences into questions. The main task is easy, as we said. You have to retrieve all nodes that are part of the subject phrase, all nodes that maybe are part of the direct object. Depending on what you want to do, this class is producing questions where the correct answer is the subject of the original sentence. I will show you an example in a few seconds. The other parts of this code here try to clean the results from typical errors that can occur by just using the approach that I described straightforwardly. Clearly, you are not going to get just very good questions by doing this directly. And you have to take care of when a pronoun appears that refers to you don't know who, or you have to take care of when you have punctuation that is left behind after removing some parts of the sentence. So there is a lot of cleaning inside this part, and clearly I do not want to go into the details here. The main point is here, for this question creator, the subject was the removed part, so we retrieved that, and we removed that by creating questions that sounded more or less like this. So these are the final results of the analysis. You have a question. In the episode, A Millhouse Divided, who throws a dinner party to escape from the doldrums at the Simpson house? We have Marge Simpson as a correct answer, a female character. Thanks to the fact that we are able to filter by gender, we were able to propose only other female characters of the series, so that it sounded a bit more logical and less obvious. And clearly you have something analogous if you use a sentence where a male character is the protagonist of the action, so the one you want to build the question about. Very, very quickly, it's not the core of the project we tried, but this is the very, very simple code for the Alexa Lambda function that we used to configure Alexa for asking questions and accepting the answers. So, very quickly, Alexa is this device that you can see here that has an Amazon Web Services service behind that is able to allow to use a voice interface for interaction of several kinds, as you can see. It uses two kinds of backend interactions, which are AWS Lambda, which is a kind of service that allows you to just configure a function to be executed without having to configure any hardware or infrastructure anywhere. Or otherwise, you can just set up a server, a web server, that exposes some API. In both cases, those are listening for requests that are starting from the device here. The way the device is configured is intent-based. So you have to provide him with examples of the sentences that he is going to hear with placeholders for parts of the sentence that are going to be different from utterance to utterance, from spoken expression to spoken expression, and he wants to use as variables in the backend logic that he is going to execute. You can have, let's say, a short-term memory of the interactions with the user, thanks to the concept of sessions. It has built-in sessions that, with which he can retain information about previous utterances and previous interaction with the user, and you can clearly build what they call skills, which are the apps for, simply the apps for the Echo Dot. Okay, so I actually just told you about this, and as a conclusion, what was done was retrieving information from both Wikipedia and Wikidata, one for text, the other for structured information to make some reasoning and selection on, then sending the text to an NLP service like the Google NLP API, and generating questions starting from the analysis that we got from Google and from the information obtained by Wikidata. Finally, it's just a way of deploying this kind of questions, but we tried to do this with the Echo Dot, Amazon Echo Dot device. There could be a lot to be done more, like creating patterns from different patterns from questions, like the one in the first example, where the correct answer was the direct object instead of the subject of the question, or it could be any complement in the sentence, whatever you want. You could try to use different entity extraction information coming from different services, or custom. For example, you could go on the serious side instead of the fun side and try to make quizzes about diseases, for example, to train physicians. And that is not available as of now from the Google NLP API, but it could be done in a custom way. And there could be a lot more things to do. Thank you. And
if you want to play with some of these TV series, just come to our stand at the entrance. And clearly. Okay, thank you.